Alright, so welcome back, and here in this lesson we're going to talk about the complex shading networks. So far we have discussed in the previous lesson that we just will start working on the particle, I guess the particle shader, which was I guess the particle cloud. And let's just do one thing. We're going to build that thing again from the scratch. Okay, so here in front of me is the shader, and it doesn't matter whatever color transparency we are taking, although we acknowledge that we're going to work for all these three: color, transparency, and the incandescence. But the case is that these three attributes would be getting controlled by the PP attributes of the particles, that is the RGB PP, opacity PP, and the incandescence PP. Now, the only confusion is that why we have to worry about the stuff. The only thing is that how do we going to sample out, or how do we going to filter out the per particle value to this shader, and finally this shader will be getting applied to the particles. Well, this case will get solved with the help of the particle sampler info. We need to go to the utilities and we'll need to create something called the particle sampler. All right. So this sampler is basically going to, you can say, what is the meaning of the sampler? It just means like a kind of intermediate that we're going to pass out the values of the PP attributes to the shader so that they could read them based upon the timeline, based upon the age, and can start sampling out or filtering out the shading and can provide them further to the shading network, and which is again at the end going to the particles supporting for the rendering system. All right. So how are we going to start building up our system? First of all, we do need to take care of some few points, and these are: we do have the opacity PP and the RGB PP, but there isn't any incandescence PP. So what are we going to do in that case? First of all, let's just go to the general and click the incandescence PP over here, you can see, and click OK. We do acknowledge that we do have the color. There is a ramp by the name of the color, and we would like to provide the same ramp to the incandescence. We just don't need to, you know, provide any other extra ramp for that. So right click, create ramp, choose the option called the color, and click OK. So with that, you are just done with the process. Now you have just applied the incandescence PP also to your particle systems. But now it's time to provide them to the software render particles, since we are using the type as a tube, and we also have the radius 0, radius 1, and the tail size that will also depend upon the velocity of the particles. Now let's just do one thing: select this child underscore burst, and first of all let's just do assign material to the viewport selections. All right, and let me just gonna name that up. Let's say we're gonna name that final underscore particle underscore shader. All right, this is done. And now let's just start building up the connections. So what we need to do in that case, the particle sampler info will going to get dropped upon the final particle shader. So this being a little bit, different from the previous versions of the Maya. So I just find a little bit uneasy to work in here with these nodes and all structure. But again, I'm gonna like that stuff. So all right, so moving forward, press the shift and middle click, drop it over here. And over here, you're going to find something called the RGBPP. So this will going to get clicked to the color. The incandescence PP will going to pass on to the incandescence. But then there is something wrong. As you can see, there is something called the opacity PP, but we don't have the transparency over here. There is no transparency PP. And technically speaking, opacity is just the reverse of the transparency. And another issue is also that the transparency is a 3-channel based attribute, whereas opacity is a single one. So what are we going to do in that case? We got a little bit stuck over here, but there is a solution. So what I'm going to do, we can rely upon the reverse utility. Now this utility will going to, transfer the information of the opacity PP to the transparency RGB. It'll also going to convert the XYZ information to the RGB as well. So what we're going to do in that case, we need to provide the particle sampler info to the reverse utility, shift and middle click, and we need to click to the opacity PP to the input XYZ. All right. Now this connection has been established. Now finally this reverse utility would be going inside the final particle shader. So shift and middle click, drop it over here, and output should be get linked up with the transparency. So with that, your maps are done. Now, as the matter of precautions, you need to go inside here. We generally don't recommend to go with the glow intensity. These things should be handled very easily and very well sophisticatedly inside your post-production packages. So just don't need to use such values. Now here I don't want to use the translucency since we are going to do the mental ray tracing process. It could be possible that the particles would start adapting the translucence effect, so which is generally never ever recommended, and rest of the values should remain same. We also don't encourage you to use the noise, so switch that thing to 0. It would be like unnecessary adding extra time to the rendering system. So with that, the particles are, the shading is completely done. As a matter of precaution, I just want all of you guys to pay a huge amount of attention over here. As a matter of precaution, the lighting is also very, very important. You just cannot render that stuff without light. And when the light comes, obviously for the particle system, the only one kind of the shadow is suited best, that is the ray trace shadow. But in this scenario, the ray trace is really a costly system for the rendering. It'll gonna take a huge amount of rendering time if you're gonna render that out for the 5 million particle count. So what you're gonna do in that case, I do have a spot underscore blue that I can obviously change that thing to the default colors, and where exactly it is located over here at the top, and this would be projecting the light towards the particles. All right, this is very important, otherwise the particles won't be appearing. And that's also another reason that's why I'm using the incandescence PV, because there is a kind of a self illumination coming out from the particles. All right, so this section is done, I guess, guys. There shouldn't be any confusions while dealing up with the shading of the particle systems. All right, now the important thing is that I was talking inside the light, there shouldn't be any ray trace shadows. If you're going to switch that on by mistakenly and you put your system to render, I don't know how long it was going to take, but in my case it was taking approximately half an hour. And seriously, there isn't any much difference in the rendering, because these all particles are already lit from their self illuminations. They were already being using the incandescence map, so there won't going to be any utilizations for that. All right, so based upon that, I just got some few interesting renders for you. This is the software renders. I'm going to go for the RGB view. In this case, I have just used the tail size to approximately 0.55. In this case, the tail size is 0.35. All right, so that was the quick discussion about the shading, and it'll going to take obviously a little bit amount of the rendering time, so your patience is required. And if you're going to see that this is highly detailed, okay, and I do remember that we still left it to talk about the streaks. All right, so let's just see you in the next lesson.